Welcome to Rediscovery, where the wonders of space and science ignite. Look up at the night sky. What do you see? Is it just darkness, or is there something more? Thousands of twinkling stars. Each one is a giant ball of burning gas, light years away, shining brightly in the vast expanse of space. Stars are the building blocks of galaxies, lighting up the universe with their radiant glow and immense energy. But they are more than just points of light. They are cosmic engines, forging the elements that make up everything we know, driving the very processes that sustain life. From the carbon in our bodies to the iron in our blood, we are all made of star stuff. The very essence of our being is connected to these celestial giants. This essay will take you on a journey through the life and death of stars, revealing the mysteries of their existence. We will explore their birth in stellar nurseries, their lives fueled by nuclear fusion, and their dramatic deaths that create the building blocks of new stars and planets, continuing the cycle of cosmic creation. Join me as we uncover the secrets of these celestial wonders and discover our profound connection to the cosmos, a connection that binds us to the universe in ways we are only beginning to understand. Stars are born in vast clouds of gas and dust scattered throughout galaxies, forming the very essence of the cosmos. These clouds, called nebulae, are like cosmic gardens where the seeds of stars are sown, nurturing the birth of new celestial bodies. Imagine a giant cloud of flour, bigger than our solar system, floating in the vastness of space. This cloud is cold and dark, but gravity slowly pulls the flour particles together, initiating a cosmic dance. As more and more particles clump together, the center of the cloud gets denser and hotter, creating a core of immense pressure. This process can take millions of years, a slow but steady journey towards the birth of a star. Eventually, the pressure and temperature at the center become so intense that nuclear fusion begins, marking the start of a star's life. Hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy. A star is born, shining brightly in the cosmos. One famous example of a stellar nursery is the Orion Nebula, a magnificent region of star formation. Visible to the naked eye, it appears as a fuzzy patch in Orion's sword, a beacon of stellar birth. Through a telescope, we can see swirling clouds of gas and dust illuminated by newborn stars, a breathtaking sight. These stellar nurseries remind us that the universe is a dynamic and ever-evolving place, constantly giving birth to new stars and wonders. Once a star ignites, it enters a long period of stability. This is the main sequence phase where stars spend most of their lives. Think of a star like a giant balancing act. Gravity constantly tries to pull all the star's material inward. However, the outward pressure from nuclear fusion in the core pushes back. This delicate balance between gravity and radiation pressure determines a star's size, temperature, and brightness. Our Sun, a middle-aged star, has been in this stable phase for about 4.6 billion years. It will continue to shine steadily for billions more. Stars come in a variety of colors and sizes, from cool red dwarfs to massive blue giants. The color of a star depends on its surface temperature. Hotter stars emit more blue light, while cooler stars emit more red light. Stellar lifespans from dwarfs to giants. The lifespan of a star depends on its mass. Surprisingly, the more massive a star, the shorter its life. Massive stars burn through their fuel much faster than their smaller counterparts. Like a car speeding down the highway, they consume their energy reserves quickly. Small stars like red dwarfs are incredibly fuel efficient. They can live for trillions of years, far longer than the current age of the universe. These faint stars are the most common type of star in the Milky Way. Our Sun, a medium-sized star, will eventually exhaust its hydrogen fuel. When this happens, it will expand into a red giant, engulfing the inner planets, including Earth. This event will mark the end of our solar system as we know it. The dramatic death of stars, supernovas, and beyond. The death of a star is one of the most spectacular events in the universe. When a massive star runs out of fuel, it can no longer support itself against gravity. The core collapses, triggering a catastrophic explosion called a supernova. Imagine a bomb billions of times more powerful than any nuclear weapon ever detonated. This explosion is so bright that it can outshine an entire galaxy for a brief time. Supernovas are essential to the evolution of galaxies. During a supernova, heavy elements forged in the star's core are blasted into space. These elements, like gold, silver, and uranium, enrich the surrounding interstellar medium, providing the raw materials for new stars and planets. Stellar remnants from white dwarfs to black holes. After a star's death, its core can transform into one of three fascinating objects: a white dwarf, a neutron star, or a black hole. White dwarfs are the remnants of stars like our Sun. They are incredibly dense, packing the mass of the Sun into the size of Earth. Neutron stars are even denser than white dwarfs. They form when the core of a massive star collapses, squeezing protons and electrons together to form neutrons. Imagine a teaspoon of neutron star material weighing billions of tons. The most mysterious stellar remnants are black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes are formed when the most massive stars collapse at the end of their lives. Our cosmic connection from stars to life. The death of stars might seem like a destructive event, but it is actually essential for life as we know it. When a star reaches the end of its life cycle, it undergoes a spectacular explosion known as a supernova. Supernovas scatter heavy elements throughout the cosmos, seeding new generations of stars and planets. These scattered elements travel vast distances, eventually coalescing to form new celestial bodies. These elements are the building blocks of everything we see around us. From the simplest hydrogen atom to the complex molecules that make up life, all originate from the heart of stars. The iron in your blood, the calcium in your bones, and the oxygen you breathe were all created in the hearts of dying stars. These elements are then incorporated into planets, including Earth, where they become part of living organisms. We are literally made of stardust. This means that the atoms in our bodies were once part of ancient stars that lived and died long before our solar system was born. This profound connection to the cosmos reminds us that we are not just observers of the universe but active participants in its grand story. Our very existence is intertwined with the life cycles of stars. The next time you look up at the night sky, remember the incredible journeys of stars. Each point of light represents a story of creation, destruction, and rebirth. They are not just distant points of light but cosmic factories, creating the elements for life and shaping the universe we call home. These stellar processes continue to influence the cosmos in ways we are only beginning to understand. We owe our very existence to these celestial wonders. Without the life and death of stars, the universe would be a vastly different place, devoid of the complexity and beauty we see today. So, keep looking up and never stop exploring the mysteries of the universe. Each glance at the stars is a reminder of our cosmic heritage and the endless possibilities that lie beyond. Thanks for watching Rediscovery, where every journey uncovers breathtaking wonders. Craving more thrills? Smash that like button, drop a comment, and hit subscribe. Let's continue exploring the unknown together.